Welcome back to our Chem 151 video series. In this video, we'll be covering a concentration problem that uses mass percent and density. Our problem says a saturated salt solution has 23% NaCl by mass. If the density of the salt solution is 1.2 grams per milliliter, find the mass of NaCl in 100 milliliters of solution. There are two pieces of information we need to analyze before we begin. First, note that our solution is 23% NaCl by mass. What that means is that for every 100 grams of solution, there are 23.0 grams of NaCl. The second piece of information says that the density of that solution is 1.2 grams per milliliter. That means for every 1 milliliter of solution, we have 1.2 grams of solution. With that in mind, we can begin with 100 milliliters of solution. Let's take a look at our information and see what can take us out of milliliters of solution. We can see that we have 1 milliliter of solution in the red line, and that 1 milliliter of solution is related to 1.2 grams of solution. Since we are trying to get out of milliliters of solution, we're going to send that to the bottom. And next to milliliters of solution, we've already written 1, and so we'll write that here on the bottom. Connected to that 1 milliliter of solution, we have 1.20 grams. That's going to go on top. Now we're going to multiply that by another fraction. Since we have grams of solution on top, we'll send that to the bottom. Now, in the other piece of information that we have not used yet, we can see that we have 100 grams of solution is related to 23 grams of NaCl. Therefore, we'll place 100 grams of solution on the bottom, where the grams of solution already is, and on the top we'll place 23 grams of NaCl. You may be able to see at this point that the milliliters of solution will cancel out, the grams of solution will cancel out, and now we have mass of NaCl left over. All that's left to do is to place these operations in the calculator. 100 times 1.20 times 23 divided by 100. We'll end up with 27.6 grams of NaCl. Therefore, in 100 milliliters of solution, we'll have 27.6 grams of our NaCl. Now, based on the information we found in Part A, we can now calculate molarity if we wish. The definition of molarity is our moles of solute, that's NaCl, divided by our liters of solution. Therefore, Part A of this process is to change our grams of NaCl to moles. Part B of this process will be to change our 100 milliliters to liters. We'll begin with Part A. We'll take the grams of NaCl and move it to the bottom of whatever fraction is coming next. We'll put moles of NaCl on the top. Anytime you have moles and grams, you will be using molar mass. If you don't know the molar mass of NaCl, you can use a periodic table to find it. We'll have to start from the mass of Na and the mass of Cl and add them together. I'll tell you that Na's mass is about 23.0, and Cl's mass is about 35.5. If we add these together, we'll end up with 58.5 grams per mole. We'll place that 58.5 next to grams, and a 1 next to the moles. Then we'll do the operation 27.6 divided by 58.5. If we go to the calculator, we'll end up with 0.472 moles of NaCl. Now we'll do Part B, where we change our milliliters to liters. Multiply by a fraction that gets us out of milliliters and into liters. According to the SI system, 1 liter is the same as 1,000 milliliters, and so we do the operation 100 divided by 1,000. 100 divided by 1,000 gives us 0.1 liters. Now for our final step, we'll say molarity is the answer from part A divided by the answer from part B. Part A gave us 0.472 moles, and part B gave us 0.1 liters. If we divide those, we will get 4.72 molarity. Therefore, our salt solution has a molarity of 4.72. Thank you for watching, and we'll see you again soon.